A primary challenge students face learning chemistry is relating the world they experience to the molecular world. The various symbols and formulas students encounter in class do little to help them make these connections. The Connected Chemistry Curriculum, or CCC, written by researchers, teachers, and students, aims to improve student learning through inquiry explorations of chemical phenomena in a virtual environment.
My main philosophy of teaching chemistry is connecting three different ways of thinking about chemicals. So you have the macroscopic world where you see everything going on with your eyes, the other senses, you're experiencing chemical reactions. And then there's the particle level where you've got these little atoms and molecules and ions moving around and colliding and bonding and bonds breaking, energy transforming those particles. And then you've got the symbolic version. What I like about the Connected Chemistry Curriculum is it actually does that. Students all have a common simulation they're looking at, and it's helping them see the particle level because there's things moving around on the screen. There's atoms and molecules moving at different speeds and rotating and interacting and bonding. And so the curriculum helps you see that. It kind of comes to life right on the screen versus a static two-dimensional image. With the computer simulations, you see all this motion, and students have to talk about that motion and what does it mean, and then how does that relate to something you see in the real world. It helped bridge the gap between what they see and then these formulas. So you mentioned sodium, the dark circles, and the green circles are chlorine. What happens when sodium and chlorine get together?
Sodium chloride.
Sodium chloride, okay. So that is table salt, right?
Yeah.
We did not only look at the computer simulation. We also then looked at video, an actual reaction of sodium metal being heated up and then put in chlorine gas, and then all this energy being released and this white smoke forming, which is actually the table salt that formed. So there was the macroscopic level, and we connected that with the particle level using the Connected Chemistry Curriculum. And then we wrote the formulas and tried to understand what all those formulas meant and use the vocabulary like atoms and molecules and ions and formula units. What I will do when they're working with the simulation is walk from table to table and just ask probing questions every once in a while. Or only N2O4, or we have a little bit of both?
It does matter. Assuming that it's at the same temperature, it should reach the same equilibrium.
It's all about student-centered learning and students being scientists and doing the kinds of thinking that scientists engage in.
Our current project examines the efficacy of CCC in partnership with Chicago area schools. We are interested in studying how our educational technologies support students' learning and help teachers implement NGSS-based practices.